if you wanted to find the number of students based on their total marks, suppose you wanted to find the number of count of the students who have scored above 220 marks from your scores data set. How can you do this? By applying this filter. Okay, please stop me at any point if you have any doubt. Okay, if something is not clear. So actually you will maintain a variable to count the number of students, and you will iterate over the cards, and then you will check for that condition. If that current card total is greater than 220, if it is greater than 220, you will increment a. So this is kind of filtering your students based on some criterion. Okay, the same thing, if here if is not followed by else block, no, in the first case, but here the if is followed by the first if. Here in the second case, the if is followed by else block. That means you will get all the students with the total marks less than or equal to 220. Like B will count those number of students. Okay, if this condition is not satisfied, then the control of the program goes to the else part. Okay, at that time B will be incremented. So basically B will count the number of students with the total marks less than or equal to 220, and A will count number of students with the total marks greater than 220. Okay, same thing. This is if else ladder, like you have multiple ifs and there is some else block. So basically you are checking for this condition here. If x dot total greater than 250, then you will increment A. If it is greater than 220, then increment B. If it is greater than 200, that means basically you will check the conditions. If the condition is satisfied, then you will execute the statement inside the if block. If the if is followed by else block, then if the condition is not satisfied, then you will you will execute the else block. So basically here you will check if total is greater than 200. If it is greater than 200, then C will be incremented. If not, then D will be incremented. Okay, only for this if. So even though you have multiple ifs here, only if this if is not satisfied, then the program will execute the else block. Is it clear? Hello.
Yes, ma'am.
Yes, clear.
Okay. Okay. Yeah, any one of you please tell, okay, if it is not clear. And if you wanted to filter the students based on the total marks and it is down, that means you wanted to check for two conditions, total marks and city town. So I'm using nested if here. So first you will check whether city town is Chennai, and if the city town is Chennai, then you will check whether the total is greater than or equal to 210. If the total is greater than or equal to 210, and if the student is from Chennai, then A will be incremented. Even though if the student is from Chennai, and if its total is less than 210, then B will be incremented. So this if is followed by else block. So how to know which is the if and how to know which else is for which if? By seeing the indentation level. If they are at the same indentation level, then that particular else is corresponding to this if. Okay, if there are multiple ifs, previously you have seen, no, there are multiple ifs, but only for last if there is this else block, because you will see the last thing. Even though if there are multiple ifs and the indentation is at the same level for if these all ifs are at same level and this else is also same level, only if this if not satisfied, then you will execute this else block. Only if the third if not satisfied, you will execute the else block. Here you have two ifs, nested ifs. The both conditions should be satisfied. Then you will execute this statement A equal to A plus 1. If this condition is satisfied, and if this condition, if extra total greater than or equal to 10 is not satisfied, then you will execute this else block. Then B equal to B plus 1 will happen. Okay. To which if block this else block is corresponds to, when this else block will be executed? Can anyone of you will tell?
If city town is not
When
Chennai.
they are not from Chennai.
Yeah, when the student is not from Chennai, then this else block will be executed. In this else block, you will check whether his total is greater than 210. If it is greater than 210, then that C equal to C plus 1 increment will happen. Same thing. Okay. Okay, this is like if you wanted to find the average. if you wanted to find the students who are above average, who are above average, if you wanted to find the students who are above average, then how will you do? Will one iteration will suffice? No, right? For the one iteration you will find average. In the next iteration you will find the number of students who are above the average. So one iteration is not enough, like one while loop is not enough. For this purpose you want two while loops, one for to calculate average of the students and the other for to find the students who are above the average. So basically in this while loop you are iterating over the cards and you are checking, you are incrementing the count, and you are adding the total. That means you are basically keeping count of number of cards and the sum of all the total marks of all the cards, and finally after getting sum and total you are finding the average of total marks. How to find average? Sum by total, no? So after getting the average you will iterate over the cards, and then you will filter the students who are above the average. So basically here you need two iterations, one for finding average and other for finding the number of students who are above the average. Okay, if you wanted to find number of pairs of students who have scored same marks in mathematics, so if you wanted to find pairs, so pairs means you wanted to compare one student with other student. If both has same total, same maths marks, then only that is pair, no? So that means you wanted to compare each student with every other student. How can you achieve this? By using the nested iterations. So while inside a while, that is nested iteration, right? So first, so basically you have this table one that will iterate over this first. Let's take the first while loop. You are iterating over the first while loop, while table one has more rows. Yes, table one has more rows, and you are reading the top card from table one and moving that particular card to this table two. Okay, moving that particular card to table two, and then read that while table one has more rows. Yes, no, the condition is satisfied in the inner iteration. Read the top card 5 from table 1, and you will check whether this dot mathematics, if x dot mathematics, that means 81 is equal to 62. No, right? They're not same. So you won't execute pair equal to pair plus 1, won't happen. So you will move y to table 3. That means you will move this card to table 3. Already you have checked this and this, you have already compared. So you will move to table 3. And in the next iteration, that means you will still be in the inner iteration, because the inner loop, the inner while loop will, here table has not become empty, no? So you will be in this inner while loop. So that row has moved to table 3, and the second, in the inner iteration, for the next iteration, that is 17 and 62, you will compare both 62 with 62, both are same, then pair equal to pair plus 1 happen, and this card you will move to table 3. So that's what. Okay, that's all. So this happens, this inner while loop will happen till table 1 becomes empty. Okay, which cards from table 3 you okay, which card you have compared with all other cards? Only the first card you have compared with all other cards, no? So for the second time you have to compare, for the next time you have to compare the second card, that is basically 6 and 81 with all other cards. Okay, so how to do that? That is done in the inner while loop. So in order to find the pairs, you wanted to compare each student with every other student. This can be done by using the nested loops. Okay, is it clear? So basically
Yes.
you have to move the rows from whatever
Yeah.
the rows. Yeah. Hello. Hello. Do
Yes,
you
ma'am.
have
You are
any?
audible. Clear, clear.
Okay, yeah. So if you wanted to, so basically what you have done is you have compared 1 and 62, this card, first card with all these cards. And in the second iteration, this outer while loop this outer while loop is for this table, this first row. And in the second iteration, in the second outer while loop iteration, you will compare 6 and 81 with all these remaining cards. So basically you will use nested iteration in order to compare each card with every other card. Okay, that's all. This is same, this is just, all these slides are just for showing you the flow, how the flow happens. Okay, in order to find subject topper of maths or physics or chemistry, how will you do? Any one of you, would you like to tell how to find the subject topper? Like, If you wanted to find max, how will you do that?
I would first do one iteration which I
The one who has got maximum marks.
Okay, I will tell. So basically, you will maintain one holder, one variable to keep track of max. So initially that will be 0, because if you keep max as some higher value like 100 or something, when you compare your data set might not have 100 at all, but your max, finally your max will be 100 only, because max updation won't happen. So your max, in order to find maximum, your variable should be initialized. The variable which you use to keep track of the max should be initialized to some less value, lower value. So basically max is 0, and you will iterate over the cards, and you will check. You now find, initially you are finding the max topper. How to do? You will check whether the particular card you are iterating, whether that max marks are greater than this max marks, the variable which you kept track for max. If it is greater, then you will update, because the max should be the current card's max marks, no, you will update. If it is not, if it is not greater, then the max remains same same thing you will do for each and every card. Then you will finally come up with the max marks. So basically what you will do is, you will check each card with the max, with each card mathematics marks with the max value. If the current card's mathematics marks are greater than max, then the max will be updated. Okay,
Ma'am,
same.
hello.
Yeah.
I think that that checking condition is some way it's wrong, right? Greater than and or equal to, because suppose in class everyone is having a 0,
uh
so it should be equal also, right?
yeah, everyone has 0, then what happens? You will end up with 0 only, no?
No, but we are
Because max won't be updated at all.
okay. No, but logic is okay, correct only. I think then, huh?
Yeah,
Okay.
if two students has got 98, then anyhow for first 98 that will be updated, for the second 98 it won't be updated, right?
Mm-hmm.
Mm. But your max will be 98 still. Okay,
Hmm.
so okay, let's take, you have 10, 20 and 98. 9, okay, 70
No,
and
that I
98.
have understood, ma'am. That I'm just asking that the greater
Yeah,
than and
yeah,
or equal to,
yeah, even if you keep greater than or equal to, that won't harm you, but
right?
greater than itself gives you the
Right,
max
right,
value.
right. So
Okay,
already MX is 0 is there. I was
yeah,
like assuming a condition where all are having a 0 mark, so it's
even
fine.
if the 0, then
Yeah,
you,
already it is 0. MX is already 0. The initiating.
mm,
Fine, fine.
okay, the same thing you will do for, in order to find the physics topper also. Same thing you will do for, in order to find chemistry topper also. Same thing you will do in order to find the highest total also. So you can see the repetition of the logic, right? Everything is same, only the change in the variable, right? Only the change in this compared value. So this thing, if you wanted to write the same logic repeatedly, you can do this by using functions. So basically you can, that is procedures you can use. You can pass a subject, basically you can pass a subject to this procedure, find max. The subject indicates the subject for which you wanted to find the max. Okay, so logic, everything is same here, but here instead of using x dot mathematics or x dot physics or x dot chemistry, you will simply use x dot subject. Okay, that will finally will give the max marks of that respective subject. So here, in order to avoid this repetition of your doing the same task again and again, you can simply use a procedure and call that procedure on that particular subject you wanted to find the max. And this is kind of procedure. Okay, procedure helps us like what, simplification of our task, not simplification, avoids repeated writing of our code again and again. So you can see this advantages of procedures. Basically by using the procedures avoids repetition of the code. So basically you have seen max physics chemistry toppers, you can find them using the single code block, that is avoids the repetition of the code, divides the complex problem into smaller ones, Yes, you can divide your complex problem task into smaller tasks by using these procedures. Okay, if you wanted to find average, and if you wanted to find somewhat the people who have scored greater than that average, that thing you can do. You can divide it into two tasks. One procedure is to find average, and another procedure is to find the students who have got above average. And it is like easy to read the code, and modifying the pseudocode becomes easier. If you wanted to modify the logic of your code, if you change it in the procedure, then it will be so it will apply for all the procedure calls, right? So for max, if you wanted to change logic here anywhere, then then in order you can avoid the repetition, right? You no need to change the code in all these three blocks. You can simply change the code in only this procedure, and still you can achieve your what required thing. So basically, I think you might have confusion with return and return versus exit loop, no? So basically, return means return statements terminates the procedures. When you encounter, when your procedure has executed return statement, when your procedure has executed return statement, then the flow of the code goes back to the procedure call. That means your procedure gets terminated, and the result, wherever you are calling your procedure, the result will be stored there, and the code block, again the control will goes to the main code. Okay, so basically here you are finding m max equal to find max of mathematics. Find after finding the after and seeing this, after executing this return statement, return max, then m max equal to that value, particular value which is written by this procedure, will be stored here in the variable m max, and these lines will be executed like p max and c max. This again the control will goes to the main code. Okay, this is simple written. Okay, you can see here example a equal to ec1 of num. So if you invoke this ec1, you are invoking this ec1 by passing some num. Some num is some value. Okay, so
Ma'am,
basically, yeah.
like while we are returning the values of particular subject, so like I'm asking like one step ahead. So particularly we have to ask the system to print that particular value or like subject
It's
value,
yeah,
or it,
it is not necessary. Actually, your this particular max value is stored in m max. So you can add your max, you can perform. This is simply a variable, right? You can perform whatever operations you want on this variable. If you get the result, you
no,
can
but
print it.
suppose ma'am, if we are all together, we have to find out the maximum by just giving the pack of the parts to the system. So we
Mhm.
have to ask the systems by calling that procedure by subject name, or it will automatically it will find out.
So you are calling, no, here you can see you are calling this by passing some subject name.
Yeah, so we have to every time we have to just give that subject name, right, ma'am? Something.
Yes, so you
Yeah.
wanted to check the argument the procedure is taking. Here it is taking subject. So you have to pass that subject.
Yes, that very okay. Parameter. Yeah.
Yeah, you have to check this parameter that the procedure is taking. Okay.
Okay.
Same. Yeah. So here you can see here EC1 of num. So that your procedure EC1 is taking some number. So basically while calling also you have to pass that. You have to invoke the procedure by passing this some whatever the value it takes. Okay, here it is taking some integer. It will check if n modulo 2, that means when n is divided by 2, if the remainder is 0, then it will return true. Okay, let us take an example is e1 of 5. If you pass is e1 of 5, how the execution will happen? It will see if 5 modulo 2 equal to 0. Is it 0? No, right? Remainder is 1. So this execution won't happen. Return true won't happen. Here return false will happen. So will the procedure continue again? No, right? Return statement is already executed. So A will store false, because procedure is returning something. So no further execution will happen. The procedure returns the value. The return value will be stored in that corresponding that particular variable. Okay.
Ma'am, what is this? The flow of the code goes back to the procedure call. What does it mean?
Yeah, the flow of the code goes back to the procedure call. That means, so here here you can see, right? Here you can see when I invoke EC1 of 5, okay, it will check whether n modulo 2 equal to 0. It's not true. It's not true. So this if block is not satisfied. So this condition is not satisfied. So the statement inside the if block will not execute, will not be executed. So this statement will be executed. Return false will happen.
I understood that, but
Yeah, let me finish.
where is
Let
it
me
is going back?
let me finish. Okay, return false. This procedure is returning false. EC1 of number you are calling, no? A equal to EC1 of number. So the result is stored, the result will be stored in A. Here you are telling A equal to EC1 of number, no? So the result will be stored in the A. So what the procedure is returning? False. So A equal to false will happen. Okay. False will be stored in A. After completing your procedure, the execution will goes back to your procedure call. That means the result will be stored in the wherever you have invoked your procedure, and the execution will continue here. If you have some more what statements here like b equal to b plus 1, then b equal to b plus 1 will happen, and it will check if if a, that means if a is true, c equal to c plus 1, you do that, execution will happen. If you have some more statements here, that statements will be executed. Okay.
So, ma'am, the return statement end the procedure here and store the value in the given variable.
Yes. Yes, it is like if you execute the return statement in your procedure, then the procedure will terminate and the result will goes back to your what the place where you have invoked the method, invoked the procedure, and then the execution will continue from that place. Okay. Exit loop basically will terminate the loop from which the statement has been called. So here you can see, while I less than n, while j less than n. Okay, basically I is starting from 1. You have initialized I to 1, j to 1, and n is 4. So firstly you will check whether 1 is less than 4, and also in the inside while loop also you will check whether 1 is less than 4. If it is same, if I equal to j, that means both I and j are initially 1, right? So 1 equal to 1, so exit loop will happen. So from which loop the execute, from which like exit loop will happen, for which loop, from which loop you will get exit. So basically which loop is calling this exit loop statement? This inner while loop, no? So you will come out of this inner while loop. So all these statements won't be executed, all the remaining statements won't be executed. You will simply come out of this inner while loop. After executing the exit loop statement, you will simply come out of this inner while loop, and your iteration goes again. Your iteration still continue again. What repeats? That means I equal to I plus 1 happen. That means I will become 2, and for 2 you will check again, this iteration will continue. Basically it won't get exited from the outer while loop, and only from the inner while loop our flow gets exited, because from the inner while loop only we are calling this exit loop statement, no? Inner while loop has this exit loop statement. So that's why only the termination of this inner while loop happens, and the outer while loop still continue. For the another new outer while loop, for the other new iteration of the outer while loop, this inner while loop again will happen. If again if I and j are same, then the exit loop of this inner while loop will happen. Again the outer loop continues. Is it clear or not? Yeah, any one of you, if you have any doubt, you can ask for this exit loop and return statement. Okay, is it clear for everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. Yes.
Okay. Yeah, okay, thank you.
Clear.
Yeah, that's all. So we have covered filtering, that means if else, and also while loop, like two while loops, two iterations. Why do we need two iterations? That also we have covered. Inner nested iterations also, nested while loops also, and then finally procedures, finding max, and then procedures, and then return and exit loop. Okay, is everything is clear, right, for everyone?
Yes, ma'am.
Ma'am, one question.
Yes, ma'am.
Yeah.
Is the procedures and functions same? Are the procedures and functions
Yeah,
same?
yeah. Basically, in CT we are calling the there are no functions, only procedures are there. So basically, they are same. But in the CT language, in the CT this course, only procedures are there. There are no functions. Okay, don't get confused.
Functions are there, ma'am. Functions are there like first of
Okay, okay.
list, list,
Yeah, yeah.
list,
Yeah,
list.
basically you won't find this kind of code blocks for function, no? They will just mention max is a function that calculates something like that. But so basically functions and procedures are same. Okay. Okay, that's all for this. Let me stop sharing
So
and
one thing, ma'am.
yeah, yeah.
If
Yes.
we have this procedure inside while loop, so
Mm.
is it called as a nested or not?
This is not that is not nested while loop, nested thing, but
Nested
the
operations,
procedure
not nested while loop. It's like nested operation, like under the while we have
see,
while
see,
procedure is calling
yeah, if the procedure gets called in the
while.
in by loop, so for every card that procedure will be called. So if inside your procedure there is another while loop, then it is called nested iteration.
So you mean to say both category should be same? It cannot be different category. Like while is calling procedure every numbers, so it's not nested, right?
So it basically won't be nested, but for
Yeah.
every card that particular procedure will be called, you
Yes.
can make it nested. You can make
Further.
that thing as nested by make inside your procedure. You can again iterate. You can use
Okay.
another while loop and then that will become nested. Okay.
Okay. Right. Under the while procedures, we have the while loop, then we can call it as a nested, right?
Yes. Yeah.
Okay.
If inside the procedure, if you have another while loop, you can call it as nested
Sure.
iteration. Yes. Okay. Oh, so just give me a minute. Okay. Just give me a minute. Then we'll move to this basic concepts are covered 3 and 4. Then we'll move to list. Okay. Okay, my screen is visible, right? So basically in this I will cover till list and list, only list. Okay, then the remaining will be continued by Bhaskar. Okay, list introduction. So basically list is a collection of values. Whatever you have seen till now is like only variables, no variables, like some a equal to some number, a equal to 10, 20 or something like that. It cannot store list of values, some multiple values at a time, no, a equal to true or something like it will store some single values at a time. But list, using a list is a collection of values stored in a sequential order. that means that means you can have, so basically this is the what this is how you will define, you will write a list. It has this what square brackets. Inside the list you will have elements of the list. So 1 2 3, these are the elements of your list. So these are sequential order. That means first element will be 1, second element of your list will be 2, third element of your list is 3. Why we are calling it as sequential order? Because inside a dictionary, if you have a dictionary, then the order, you cannot predict the order of your elements. But if you have a list, then you can predict the order of your elements. Then the first element is 1 and second element is 2 and third element is 3. That is why it is called sequential order. List can store values of different data types. That means you can have one, that means integer, string like ABC, or false something. You can store values of different data types, integers, strings or booleans, anything you can store in a single list. Okay, list can store duplicate values as well. That means 1 1 1 something like that, 2 2 2 also you can store in a single list. So first element of your list is 1, second element is 1, and the third element of your list is 2. So it can also store duplicate values. List preserves the order of elements in it. That means first element, whatever I have told earlier. An element in a list can be another list or a dictionary. So you can store a list inside a list 1, 2, 3, or else 4, 5, something like that. You can store a list inside a list, and also you can store a dictionary as well inside a list. Dictionary has basically key value pairs like one, something like that, B2. So you can basically store what a list inside a list, and also dictionary inside a list. Anything you can store inside a list. Any data types also you can store inside a list. List is initialized using this square bracket notation, and if the list is empty, then the length of your list will be 0. Length is the method, or the function. Length is the function which finds the length of elements of your list. Okay, length of this particular list is 3. It denotes the length of your list. If it is empty list, then it will be 0. Length of your list will be 0. So if you wanted to add, okay, you have empty list initially. If you wanted to add elements to your list, then how can you do this? By using this plus plus operator. Using this plus plus operator, you can add elements to your list. So if your list is 1, 2, 3, if you wanted to add 4 to your list, then you can say L. Let us take L. This list as then you can say L equal to L plus plus 4. That means your list will contain, now L will contain 1, 2, 3, 4. So you can add the elements to your list by using this plus plus operator. And you can see here I have kept this 4 also inside the square bracket. That thing also you have to follow in order to add the elements. You can add a list also to a list. So if I say L equal to L plus plus something like 5, 6, 7, then you wanted to keep a list inside a list. So if you wanted to add a list to a list, then you have to use this double square brackets, and that means basically you are adding a list to a list. Okay, your list will become 1, 2, 3, 4, and then 5, 6, 7 will be added to your list. Okay, is this clear for everyone? List operations?
Yes,
Yes.
ma'am.
Yes, ma'am.
Yeah. Okay.
Ma'am,
Yeah.
ma'am, I had a question.
Yes.
Can I randomly access a variable? Say I have stored a variable in the third place in the list, so can I directly access that, or do I have to
No,
sequentially
directly
follow?
you are not able to access here. You just have to iterate over the list. For each X in L, you will just iterate over the list. Okay. That's how
Ma'am,
you, yeah.
ma'am, the way just now you told like how to add a list in a list, can you please show one example for adding a dictionary in a list?
Okay. Yeah. Okay. Adding a dictionary in a list, no? So L
Yes.
equal to L plus plus. Basically, in order to add anything to your list, you have to keep in square brackets. Okay. If you wanted to add element, then you will simply keep element in the list 4 or something, anything. If you wanted to add another list, you will add list here. If you wanted to add dictionary, you will keep in dictionary, and you will say some dictionary here, some name is Rahul or something, name map it to something like his age 23 or something like that. So dictionary will be added to your list.
Ma'am?
Okay. Yeah.
Ma'am, how to access that particular dictionary from the list?
So basically, you have to iterate over the list in order to access the elements of your list.
So that
basically,
dictionary becomes one element, is it?
yeah, dictionary will be one of the element of your
One of the elements,
list.
and then okay, we access it as, suppose that is the fourth element, then we access it as a member of the list. Then subsequently, to do the operation inside the dictionary, how do we do it? Can you give it? Can you just show us one example, ma'am?
Okay, you will first iterate over the list. You understood, right? How to get to a dictionary?
Yeah. How to get the member, we know.
Yeah, so for each X in L, that means for each element, some element in your list L,
List,
you,
yes.
yeah, for each X in L, you can say this is like you will get each and every element of your list. If if you have given some name to your dictionary, if x equal to is some dictionary is D, then you will iterate over the dictionary. How to iterate over this dictionary? For you will basically, in order to iterate over the dictionary, you have to iterate over the keys. You cannot directly iterate over the so so basically, I will show this here. I think it will be more clear. Okay, this is not there. So for each k in, so basically you will write similar for each loop. So for each k in keys of D, that means keys of D is some method. Keys of D is like keys of that particular method.
Here it is Rahul, I think.
List
One
of
key.
dictionary.
List keys of X, keys of any dictionary will give the list of keys of that particular dictionary. Here we have only one key, that is Rahul, so it will be given as list. So Rahul will be given as list. So same for each loop you will get. For each k in some list you will iterate, no, same thing it will happen. So in order to get the value of that particular element in dictionary, so if X of k, that means if you have dictionary D, you will say in order to get that values of your dictionary, you will access that by using the key, D of k, key equal to some value you will get. In order to assign the value, you will say D of key equal to value. In order to get the value, you will say D of key. That means it will give the value corresponding to that key.
Basically, when you access the element, which is the dictionary, you assign it to a variable and start the operations as usual, as we do it for any other dictionary.
Any other dictionary, yes.
Okay, fine. Thank you, ma'am.
Yeah. Okay. Yeah, this is very clumsy, So yeah, is this clear for everyone? Please stop and ask, okay, if you have any doubt, don't hesitate. Okay, list in order to list operations. So in order to add element to your list, you will use plus operator. Okay, if you have two different lists, L1 and L2, if you wanted to merge this two list, a single list, that means your output should be 1, 2, 3 ABC. So then you can simply use L1 plus L2. So you will get 1, 2, 3 ABC in a single list. If you wanted to add some element to your list, then you will say 1, 2, 3 L plus of that element X. You will keep that X in the square brackets. You should keep that X in the square brackets. Okay. Then only this will work. If you simply say L plus X, then that won't work. Here it is working because it already has the square brackets, no? Yeah. If L equal to 1, 2, 3 and X equal to 4, if you wanted to add element to the beginning of your list, then you can say X plus L. First X, then followed by L. Then 4, 1, 2, 3 will happen. Okay. Okay, L plus X or X plus L are incorrect statement because X is integer variable, not a list. Okay, that's fine. If you wanted to add list to a list, then you can do this by using the square notation. L1 is already a list. L plus of L1, that means you will get a list inside a list. I have already shown it. Okay, same thing here also. Adding a dictionary to a list, that you can do by using same thing, whatever we have discussed earlier. L plus inside the square bracket, you will give D1 or some dictionary, whatever dictionary you have to insert in your list. Okay. Okay, this is some good chart. Okay. If your list is empty, then the length of your list is 0. And first of your list your list will give the first element of your list. Last of list will give the last element of your list. Rest of list will give the list after removing the first element of your list. And init of list will give the initial part of list after removing the last element of your list. Basically, the output of first of L and last of L is it's not a list, it's an element. But rest of L and the init of L output is some list again. Okay. Okay, if your list is empty, then the length is 0. If the first and last of that particular empty list is undefined, because you don't have any element in your list, so you cannot get the elements, no? So it is undefined. But rest and init of our list of your empty list is again an empty list. Okay. If you have 10 as element of your list, the length of list is 1, and the first of list is 1. That means first element of your list is 10, and also last element of your list is also 10, same. After removing the first element, there is nothing in your list, so it will return rest of list will be empty list. After removing the last element of your list, that means after removing the 10, again the init of the L will be the 10 empty list only. Okay, let's take this as example 1 2 3 4. First length here, length of your list is 4, and the first element of your list is 1, and the last element of your list is 4. And after removing the first element of your list, the rest of your list is 2 3 4. It is a list and it is 2 3 4. And after removing the last element of your list, that is 4, the init of your list will be 1 2 3 4. Okay, 1 2 3. Okay, 1 2 3. The same thing for it, if even if your data types of your list is string. So basically first will be A, last will be C, and rest will be BC, and init will be AB. Is it clear for everyone?
Yes,
Yes,
ma'am.
ma'am. Yes,
Yeah.
ma'am.
Yes, ma'am.
Yeah. Okay. So if you take this list as example, so here first will be 2 and last will be A. So what will be the rest of your list? Rest of your list will be the list after removing the first element of your list, that is B31CA. So what will be the init of your list? The list after removing the last element of your list, that is after removing last element means that is after removing the A. Your list is 2B31C. Okay. Same thing here also, everything is same. So yeah, everything is same. Okay, here if I say ABC, length is 3, first element is A, and if I say first of rest of list, can you tell what is the first of rest of your list? First of rest of your this
B.
ABC list. So it is B. It is B. Right? Yeah. So first of init of your list is this list is
B.
2.
Which one? B.
B.
A.
First of
Top
init
A
is
in
2.
it.
Yeah, first. Yeah, A.
To
It's
which
A.
one? Which list? This, sir.
This list.
To B.
It is
It will
A.
be
A.
Yeah, it is A. First of init of your list. So init of your list will be after removing C. That is AB. And first of you AB is A. Okay. Okay. Yeah. So if I say first of for this list, if I say first of init of L, then what will be your list? For this list, first of init of your list, what is
2.
it?
1 2 3.
1, 2,
Yes.
3.
3.
The list 1 2 3.
List of 1,
Yeah,
2,
list
3.
1 2 3. Yes, list 1 2 3. It is list 1 2 3. Okay. Okay, last of rest of your list. This list last of rest of your
27.
yes.
27.
Yeah, this kind of this will be very clear if you understand first, last, rest, everything. Okay, it is simple only. Yeah, that's all. Bhaskar is there. Bhaskar, are you there?
Yeah, I'm here.
Yeah, should I stop here? Would you like
Okay,
to
fine.
continue? Yeah.
Yeah. Just a second. I think my screen sharing is not is disabled. I have to check. Wait.
Yeah, should I
Ma'am?
message? Yeah,
Yeah,
yes.
can you message me?
Yeah. Okay, you have not joined as pod, no? Just Bhaskar Banerjee or anything?
With
The
my
Bas-
own
yeah,
online
yeah,
ID
okay.
only.
Okay. No, I'm asking for name Bhaskar.
Yeah,
Banerjee.
yeah.
Yeah, meanwhile, we can continue, I think, Bhaskar, for insertions, or you can just give something. Yeah, so oral
Yeah, so
discussion.
yeah, so fine. So let's do that. So anyways, I would be starting with the dictionary part, and today we would be focusing up to, and also the insertion sort I would discuss. Then we would move into dictionary. Okay, and after that we would see some codes, and up to week 8 we would cover in this session. So let me see.
Sir,
Yeah.
what is the weightage of the for the end term, sir? Weightage as per the weeks?
There is no specific, I mean, any weightage or that has not been decided like that. But obviously, see, initial weeks, whatever content is there, that would be required for your, I mean, in the advanced weeks, right? Let's say when you are writing pseudocodes and dictionary on list. So obviously, you need the if else while loop and all those concepts.
No, yes, that is true, sir. But actually, in maths and all, they have given the weightage as per the weeks. So that's why I just wanted to know, if, maximum questions will it be coming from the last 4 weeks, or how is it? It will be equally distributed.
See, last 4 weeks questions would be a bit more. That's correct, because those things do not come in any of the quizzes. But yeah, distribution would be obviously it would be a little more weighted towards the last 4 weeks.
Okay.
But nothing very specific week wise.
Okay.
In maths, I would say there is still the sense of having weightage. I mean, distinct weightage makes sense because there is varied topics. But here, if you do not know week 3 content, you cannot write code in week 8.
Yes, sir.
Yeah.
So, what's the good marks in this subject for a candidate?
Good
Means
marks.
around scoring, yeah.
That I cannot tell actually. I mean, what I mean.
So means like in assignment, I was expecting something better, but it didn't go that way. So just wanna confirm. So means
See, it
what's
all depends on the how the average comes out, right? So, how the overall performance of the batch happens.
So,
So,
sir, up till now, how is the performance of overall batch? Like on an average, how much is the score?
so I have not seen that. Okay, I have to then confirm that. Okay, I don't know it as of now. Yeah. Fine. So, is my screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
Fine. So this dictionary concept, okay, before moving to dictionary, I would discuss insertion sort from the list, that's there. But before doing that, I just want to say that dictionary concept is very important. It's not difficult, it's quite easy to understand. Once you understand it, the only thing is the different kinds of, you have to practice a bit more pseudocodes. I mean, at least practice some practice questions that are already given to you. So you can just see through them, and I think then it should be fine. Because unless and until you are quite comfortable with the dictionary and this multiple nested list kind of concepts, the further weeks concept like graphs and then applying DFS, VFS, or sorry, VFS is not there. I mean, the depth first search algorithm on graph, right? And the matrix creation of graphs, all those things would be a bit more difficult for you to understand. I would actually discuss a little bit about how to represent basically a graph, and then I would end it because that would be a part of the next weeks. So that would be taken in the next revision session. But I think in one of the session or open session I discussed in detail about how you represent graphs, what are the different ways to do that. So that's why it's important. Dictionary concept is very important, and you should focus properly on these contents, because yeah, many questions would be coming from here as It's actually the last part of the week, of the course as well, and plus it encompasses all the different topics that we discussed as part of this course, because it needs you to go through loops, through iteration conditions, different kind of things. So yeah, you can expect a bit more question from these parts. Anyways, so
Sir, your voice is echoing.
is it echoing?
No, sir.
No, sir, no.
Perfect.
No. Okay. Still, let me just. Is it still echoing?
No, sir.
Okay.
No, sir, it's not echoing. It's perfect.
Okay. Great. So before going to discussing insertion sort, pseudocode and the normal things, so how many of you actually understood insertion sort properly? I mean, the concept of insertion sort. Can you raise hands? Can I see? Fine. Okay. So I would just discuss that anyway. So let us see. What is first of all, what is sorting? What do you mean by sorting? So these things, if we would learn multiple kind of sorting in your
They
further
arrange
courses.
the elements in
Arranging
ascending
or ordering
descending
things
order.
according to the size or type or something.
Okay, fine. Great. So yeah, it's arranging. Sorting something means you're arranging depending upon value or some other properties. Now in this course, we would only see depending upon value. Okay, so we are arranging the data that we have. Now, initially we had, in our initial weeks of the city, right, we had tables in which we stored record, but now we have learned about other ways of storing data, and ways means different tools that we have to store a set of data, like list, like dictionary. Dictionary have not come yet, but anyways, so these things are different ways of storing data. Okay, and you can use these ways to actually store data as well as modify or work upon them to do some useful tasks. So in a list, we would see in this course, we would see that how you can apply insertion sort in a list where multiple elements are there, and you are just sorting them, you are arranging them within the list only in a sorted order, maybe ascending, maybe descending. Okay, so that's the idea. But let's see that how insertion sort works. So first of all, why a name is given to a sorting like insertion sort? Because there are multiple other ways of sorting as well. Okay, so those things we would discuss in detail in the PDSA course. So there we would see that there are different kinds of sorting algorithms are there, where we would see there are advantages and disadvantages of each of one of them, depending upon various other factors. Some are good in some scenarios and some are good in some other scenarios, right? So insertion sort is a very simple kind of sorting, primary kind of algorithm, and how it works is, and that's why it is called insertion also. So we are assuming that, let's say this is our list, right? And let us assume that at some instant of time, just start the thinking from the middle, right? Just assume that however insertion sort works, it has worked for, let's say, some number of times, and it has sorted up to this much part of the array. I mean the list. Okay, the left side, this left side of the list, it has sorted, and right side from here actually it's not yet sorted. So now your current iteration is on this element, right? On this element. So how it works is insertion sort. It would pick this element, okay, and then it would place this element on the left sorted part where it belongs. So let's say, what do I mean by where it belongs? So let's say, obviously I told you that this part is sorted, right? So let's say it is 4, 12, and let's say 38. Fine. And let's say this element is your 25. Okay. This element is 25. So obviously it is sorted in an ascending order. And when you pick 25, where should it actually belong? It should belong after 12, right? Here it should belong. Because if I have to maintain the sorted order, so 25 should be put over here. Let's say it was not 25 and it was only 5. Fine, it was only 5. So then what would have been the correct place? So Correct. So here I would have placed. So this is what insertion sort primarily does. It picks the current element, right, from the unsorted half of the array. One by one, it will pick all the elements and then place it in the sorted part, sorted subpart on the left hand side in its correct position. So once you do that, what you actually did was, once you place 5 over here, what you did is actually you move this boundary one more level ahead, one more cell ahead. So there your boundary shifts. So your size of the sorted array increases. Right? So that's how insertion sort works, and that's why we call it insertion sort, because essentially what you are doing is you are picking one element from the unsorted part and inserting in its proper location on the sorted part on the left hand side. Fine. So this is how it works. Now, how we will achieve that is we would go to the code and you would see. Now, a very important part of the thing that I was telling, that there are different sorting algorithms. The reason for that is they work in different conditions in different manners. So one of the primary property on which we judge a sorting algorithm is how much time does it take. So to say, in any algorithm we judge that how much time does it take. Algorithm means technique. Okay, so the way that so this particular technique of sorting, insertion sort, so that is one algorithm. Okay, we would come to the meanings of those terms in other previous course, but anyways, so that's what if I use the word algorithm, just assume that what I'm telling is techniques, different techniques. So mainly one of the property on which we judge a particular technique is how much time does it take, or how many number of iterations it has to go through before completing the sorting process. Okay, so but that is not there in this course, so we would not go into the discussion of that. But I'm just mentioning that how many iterations, how many times this work has to be done, actually is a measure, is a metric of how good is your algorithm, how good is your sorting technique. So if I give you a example, what I mean is, okay, so let's say my list is something like this. Fine, this is my list. It's in descending order, and I have to sort it in ascending order. Okay, I have to sort it in ascending order. Now you apply insertion sort. What would happen? So obviously you start insertion sort always starts from the second element, because anyway your first element has no other element on left hand side, right? And our whole motive is to put an element on the left hand side. So I start from 9. Okay, and even if you start from the first one, it doesn't make sense. Your iteration would be on itself only. So 10 would be in its place only. So anyways, so the meaningful iteration starts from 9. So I would start from 9, right? And then I would check whether the left hand side. So when I consider the left hand side, considering this part, this left hand side is sorted, right? Why it is sorted? Because only one element is there. So it is trivially sorted. There is no other element. So only 10 is there, and therefore we can call it sorted, because there is no comparison of 10 with any other element. Now I pick 9, right? And I have to place 9 at its proper position. So we would try to count how many comparisons it is taking, right? So I'm just writing here comparisons, number of comparisons. Okay, so this might come in as an MCQ, maybe, right? Or a NAT in your exam.
So my sorted list. So my sorted list will be empty initially, right?
Sorry,
or it will sorted list will be empty, right? Or it will contain the first element.
Sorted list would be empty means
so when we start iteration.
I was telling that sorted list. Okay, in the code you are telling, right? So sorted list is that we would put that list in the code. We are actually creating a separate list where we are putting the values, right? Okay. So that is fine. But what I am telling is how we are doing it. How many comparisons does it take? So if I compare 9 with 10, that is one comparison. In order to place a new element at its proper location on the left part of the list, I have to find its proper location, right? And in order to find its proper location on the left hand side, I have to know that from which element it is larger and from which element it is smaller. Once I know that, then only I would be able to place it at its proper location. So that is what I am talking about. Let's say if I run insertion sort on this list, right? So how many comparisons will it take? right? So let us see that. So I start from 9 and I compare at first 9 with 10, and I see that 9 is smaller. So I must place 9 before 10. So my list is modified. 9 is over here and 10 is over here, right? And let us remove that. And that is one comparison, right? I compared 9 and 10. Let us go for 8 now. So left side is sorted. Now 8 is the next element. So I pick 8, and now let us compare 8 with. I have to find the proper location of 8, right, on the left part. So what I would do is I would again first come to 10 and compare whether 8 is greater than 10 or not. And I see that 8 is not greater than 10. 8 is lesser than 10. So if 8 is lesser than 10, obviously it should belong on the left hand side of 10. So, but I cannot place directly 8 on the left hand side of 10 because I know there is some other element there which is 9. So I must also see whether what is the relation of 8 with 9. So again I check 8 with 9. So first comparison was 8 with 10, and that was 8 was lesser than 10. So that is one. And then I compared 8 with 9. So that is another comparison, and I saw that 8 is even lesser than 9 as well. So I must place 8 over here. Right, so this is where I'm creating the new list. As you see in the pseudocode on the left hand side, I'm just appending at its proper location. It would go to the pseudocode, don't worry. So, so 8 was placed before 9 as well. So 3 comparisons we have done. Now let us, so 8 is removed. 7 is there. Same process would happen, right? So again, I would at first compare 7 with 10. That would be one comparison. And I saw that 7 is lesser than 10, so I must compare 9. So you go 7 and 9, and you see it is even lesser. So another comparison you did, and again 7 with 8 you would compare. That is another comparison, and finally you would place 7 over here. You see what's happening over here. We are actually since this was sorted in the other way and in the descending order, and we want to sort it in ascending order. What's happening actually is whenever I pick a new number from the unsorted part, it has to go through all the numbers that are there in the sorted part, because every time my new number would be the smallest one, and every time it would be placed in the front, right? So every time the new number that I pick from the unsorted part has to go through the whole length of the sorted part. I mean comparison in terms of number of comparison. So when I pick 7, how many comparison it would go through? With 7, with 8, with actually in the order of 10, then 9, then 8, and 7. So 4 comparisons. I would add 4 over here, 4 ones, right? So, and how many comparisons did, by the way, 7 go through? 7 went through 10, 9, and 8, 3 comparisons. So these 4 comparisons are corresponding to placing 6. These 3 comparisons are corresponding to placing 7. These 2 comparisons are corresponding to placing 8. Yeah, and this one comparison is corresponding to placing 9. So this was 9, 10. This was 8 with 10 and 8 with 9. This was 8 with 10, 9 and 10 and 10, 9 and 8, and 6 with 7, 8, 9, 10. 4 comparisons. So you see, every time I am actually going through the whole length. So for placing each element, we are having many number of comparisons. Now just consider the other array. So if I repeat the step for 5, it would have 5 comparisons. With 4, it would have 6 comparisons, right? So if I just modify the array list and see what happens in another example where I just kind of modify the list. Right? By the way, how many would be the final answer of it? It would be plus. There are 4 ones, right? So for 5,
21
it would be,
maybe.
Yeah, 5 ones, and for 4 it would be 6 ones. So whatever it is, right? So actually it would be an inter minus 1 by 2. That's n plus 1 by 2. That summation would be there. But anyways, so you can count whatever it is coming. But now if I take another list which is sorted in the order we want it to be, so already sorted this. So 1, 2, 3, 4. Let's say 5, 6. 1, 2, 3, 4, 5, 6. Fine. So this is one list. Again, I start from here. Now you see how many comparisons are happening. Okay. So how many elements were there? 1, 2, 3, 4, 5, 6, 7. So let's take the same number of elements here as well. So comparisons now see. With 2 you compare 1, and you see that 2 is greater than 1. So 2 is already in its correct position. I do not have to move anything. I mean 2 ahead of 1. So but you compared obviously once. You compared 2 with 1. So that is one comparison. So okay, done. Then you go to 3. Fine. And you now see, let's compare 3. And I told you that every time the comparison happens like this, right? Then you would compare. If needed, then you go to the further left. So now you compare 3 with 2 because this is your sorted part now. So compare 3 with 2. So that is one comparison. But now you see 3 is greater than 2. So since 3 is greater than 2, and obviously I know that this is anyway sorted. So 3 must be placed after 2. I do not need to compare 3 with 1. I know that left hand side is sorted and 3 is greater than 2. That means 3 must be placed after 2. So all I have to do is just shift the sorted part over here like this. So I need not require compare 3 with 1 because it is sorted in the favorable order, in the same order I want it to. The data is given to me in that manner. So comparison of 3 with 2 is only one comparison. Comparison with 2 with 1 was only one comparison. Accordingly, if you proceed, same thing would happen throughout all the numbers. When you check 4 with 3, right, you would see that yeah, 4 is greater than 3, so must be placed after that. So only 1. So along for 5, 6, and 7 also, you would have only one comparison.
So total 6 comparisons.
So you see that then this is what total 6 comparison. And if you see this one, so this 21. Is what 21 comparisons. Okay, so this is actually, you see, if you generalize it, if you have n numbers in the list, right? So your number of comparison in this scenario, in the best case scenario, would be n. Yeah. Okay, and here what it would be the scenario? It would be actually
n into n plus 1 by 2.
Yeah, summation of n. Fine. So this is one of the feature on which we judge different algorithms or techniques, because in worst case possibility, if I give in a different order of the list, in the opposite order of the list, insertion sort can take a lot many number of comparison. And again, if you give it in the same order, in the correct order, it would at best it would take only n minus 1 comparison. And any random order. So these are both sorted order, right? This is the totally opposite sorted order, and this is the sorted order in which we want the list to be maintained. So these are two extreme values, two extreme conditions. All the random condition, unsorted condition in between lies between these two the highest and the lowest values. I 6, I know. Right. So any possible combination of your this list of 7 elements would have values ranging between these two numbers. So that's it. That was everything about insertion sort. Now let us go to the code. Now since you know these things, how it is working now, insertion sort. Now we could just track the code, how the code achieves it.
So why we are going from right to left? So in the first instances, when we had selected 10 and we had already placed 9, so why did not we go from right left to right? Like, we could have directly compared it with 9. Or
correct. Correct. So let us take this example to answer that question. So if your list is, take this example. Okay, 1, 2, 3, 4, 5, 6, 7. So if I would have started from, your algorithm cannot, your code will not change depending upon what is the scenario, right? How you are working with it. So the list values would sometimes come different and other times different, but you cannot change your program or your pseudocode.
So we have to, by default, we have to go from right to left while comparing.
Correct. So
for
because
any order for ascending as well as descending.
No, the code is implemented in general way without thinking about ascending, descending. Only ascending, descending would be this greater than equal to sign.
And we'll put a condition, yeah. Okay.
Yeah, that would change.
Thank you.
Right. Okay, so fine. So we would deal with the whole insertion sort thing, how we achieve that in this, but before that, this is actually not the full insertion sort code. This is a part of it, and by part of it I mean, yeah. So this code actually inserts only a given element X, okay, a given element X into a list L. Now I am assuming that list L is a sorted list, right? So initially in our discussion we saw that let us take the list and divide it into halves. So this would be the sorted part. So here you assume that L is just that part. Here we are considering different list, not a single list, right? L is the sorted list. Now how we are actually, given a list, a complete list. So let's say you have a whole list like this. right? And that is unsorted, obviously. You have to do the sorting, right? So that how we will achieve, we would see later. But as of now, in this code on your screen currently, this code is doing what? Given an element x, it is putting the x element in a sorted list at its proper position. So L is already a sorted list. Okay, so we have list L arranged in ascending order. Fine, just think about that. Once we deal with this procedure, then we would see how we can use this procedure to apply the insertion sort idea. Insertion sort idea did not it did not assume that your list would be sorted, right? I mean, obviously, the main idea was it is unsorted list, and what you have to do is sort it. But here we are saying that already sorted list is given. All you have to do is insert an element into that. Now you can guess actually. So what we are doing over here is, since in the insertion sort we were taking a sorted part, right, in the same list and inserting the first element from the unsorted part at its proper location. So this operation is essentially what we are trying to replicate. Okay, we are not bothering about the whole unsortedness of the list, but only this part, that you take a element and put it in an already given sorted list at its proper location. If we can replicate this operation or this behavior in the method that we are currently in the procedure that we are currently discussing, once that we gain that, we can then use that method to actually implement the whole insertion sort idea of unsorted, this whole list being unsorted and doing sorting that, right? You would go to that after that. But now let us see this only, that you have sorted list and x has to be inserted in its proper location in the list. So what we are doing is, at first we are actually creating, we are approaching here by making a new list, and we are keeping it empty. New list would be the list which would be the sorted list, and that's why we are returning new list at the end, because that would be actually sorted. It would be maintained in the sorted order. So x would be there in the new list at its proper position. Fine. Okay, so then we are using this inserted one variable and keeping it to be initially false. Inserted would be made true when x actually got inserted into the list, right? So then we would make inserted equal to true. Now the way that we discuss the insertion sort working, right, that is exactly what's happening over here. So if you keep that idea in your mind, and now let us go through the code. I hope it would be easy to understand. See, what we are doing is, assume this was our this is our sorted list here. Okay, this is our sorted list here, and we told you that we start from here and go one by one, right? So but since this is not exactly insertion sort, I mean, this is just inserting an element into a sorted list, so we are starting from the beginning one, right? Doesn't matter, from any one of the end you can start, but the convention is you start from, while in insertion sort you start from the right end, right? But again, you can do it in any possible manner, it doesn't matter, as long as you follow the rule of insertion sort, and that rule is choose the element, put it at its proper place, right? So now we have this list, okay, and we are for each z in L, so obviously your z would be, you just a second, yeah, so for z would be starting from here, so let's say this is your z, first z, and z in L. If not inserted, so yeah, inserted is false, so not of false would be true, right? So this if statement would be executed and we would move in. Now what we are doing over here is we are checking whether x is lesser than z or not. I mean, the given element that we have to insert, that we are checking if x is lesser than z, because I have to sort it in ascending order, right? So I'm checking whether the value that I need to insert, whether it is lesser than my list and the element in the list. If so, then I would try to place x before z, right, somewhere over here. So basically the list would look something like this. If not, then I would see what I have to do. So let us see that if so let us assume that if x is actually lesser than z, it is true, right? And then what I would do, obviously I told you that we are actually creating the sorted list in a separate list called new list, right? So since I know that now x is lesser than the first element, because this is my first iteration, and x is less than z, which is in this iteration it is my first element in the list. So I know that my list should look like x followed by all other things that were there in the given list, I mean in L, right? So now I can just create my new list according to that. So what I would do is I would add new list plus x, right? What was new list initially? It was empty, right? First new list was empty, there was nothing there in new list. So empty plus x means what? What would new list look like? New list would look like new list NL equal to it would look like first x would be there. And this is your new list after this line of code. And obviously now you insert x, so you make inserted equal to true. Fine. And and then you close your if condition and closes. Now what is left? You add x over in the new list at its proper position, but you have to still add further all other elements which were there in the L list, right? In the list L. So what you do is you again move to the next for iteration. Okay. And obviously you add z at each level. So that's what I was telling. So you have to add each element which is there in L, right? So currently that element which is in L is z, right? We are using z to track that element. Z is the variable which is tracking each element in L. So every time we actually go through this loop, we would add z after in the new list. So once x is added, when we are at this line, new list would look like new list equal to x and then the current z. So I am just mentioning to be z1 because this is the first iteration. So after the first iteration of the for loop, right, and when we complete this line of code, we get the list to be xz1, and accordingly it would. But next time when we go to for the second iteration for z2, right, for the second element over here, let's say this is z2. Fine. You see the not inserted would not actually, this would actually fetch you false because inserted is now true. You made inserted equal to true in the first iteration. So inserted is true, not true of that, that would be false. So if false. So this part of the code would be ignored. So you would directly come to this line of the code, which is new list plus z. And what is z currently? Z2. So again, your new list would be at this line in the second iteration, x, z1 and z2. And accordingly, so you would see that you would add all the elements and you would finish the whole list. Fine. So this is the scenario in which x got to be true in the first instance only, and it is placed on the extreme left. But let us see a normal other scenario where x is not true in the first condition. Then how it would work is, fine. So now let's say this is my again list. Fine, and this is my z, the first z1 I mean.
Sir, excuse me, sir.
Yeah.
Sir, I didn't get the step if x is less than z. Sir, please explain the system.
That's what I did. X is less than z means what? Z is what? Z is each element in the list. And when for x z in L I am doing, what does that mean? Z, the first iteration of this for loop would correspond to the first element. That's what I was telling, z1. I mean the initially, right? The first element in the list. So if x is lesser than the first element in the list, in the very first iteration of the for loop, you get this to be true. Then what does that mean? That x is lesser than the smallest element, because this list is anyway sorted in ascending order, and that means the first element is anyway the smallest element. And you see that x is even smaller than that. That means x must be in the starting of the sort. I mean, the proper position of x in the sorted list must be at first, correct? So once
So can you take a numbers 1, 2, 3, 4, and so it will be easy.
No problem. So let's say 4, 9, 10, 12. So these are sorted list, and let's say your x is 1. Okay, so what would happen at x what would be z in the first scenario? In the first iteration, z would be 4. Correct? Because z starts for each z in L. So this is z. So you see that x is 1 and z is 4. So 1 is lesser than 4. So new list was initially empty. So this was empty, and this is what? X is 1. Right? So inserted is 2. So at this point, new list becomes what? NL is equal to 1. Done. So you made inserted equal to 2 and you move out of the if statement in this line of code. And then you see that new list is new list plus z. This line is doing what? When you initially, once you get this condition to be true, that means you got the proper location of x. Our whole idea over here is to get the proper location of x. Once I get that, I would put x. And I would make inserted equal to true. That would mean that I have placed x. That's the whole duty of this whole procedure. Okay. So once this is done, that means you have put x. What's the only task left? That since I am returning the new list as the sorted list, I have now put x at its proper location. All I need to do is put all other elements which were there in L into this new list, and then I would return the list, right? So that is done by this line of code. That every time Z is what? Every time you're iterating 4, 9. So initially first iteration Z is 4. Once I move to the next for loop iteration, Z would be 9, right? Z would be 9.
Yeah.
So if I have to add each of the element in this list, in the new list after 1, right? Since 1 has been already placed, right? So all I have to do is simply add Z in the new list. That's what this line is doing. Here, new list plus plus Z. So every iteration Z changes, Z becomes 9, and obviously this condition becomes false, right? Because now you have inserted. Not of inserted. What is inserted now? Since in the first iteration you made inserted equal to true, so not of true would be false in the second iteration. So if of false would be false, so this part of the code would be ignored. This whole part would be ignored because this part is corresponding to this part is corresponding to your insertion of X. Now you have already inserted X, so you ignore this part and directly come to this part, and what it is doing is it simply adds the Z into the list. That means 9 in this case. So in the second iteration of the for loop, my new list after executing this line would look like 1 followed by 2. 4. Okay, so 4 would be there in the first instance only, not in the second instance. It would be 9. Because initially you inserted 4 in the first iteration, and then in the second iteration you inserted 9. So 1, 4, 9. Third iteration, what would be the list look like? NL would look like 1, 4, 9 and followed by 10. Right? All this part would be every time it would be ignored because this condition is becoming false every time. Because in the first iteration you made inserted equal to 2 and not of true would be false every time. So this part is ignored, and every for loop iteration is only executing this line of code to add the elements in the list. In the L list in my new list. So in the last iteration, NL will 1, 4, 9, 10, and 12. That's it.
So, sir, here also we will do like 4 minus 3 by 2 comparisons, right? 4 into 3 by 2.
Correct. Same thing. Yeah. That's all. It's insertion sort only. It's same. But not sort. So insertion sort was happening on an unsorted array, and here we are just comparing a part of that, an operation of that. Given a sorted array, we have to put given a new element, right? So once we achieve this, you can actually guess it that once we achieve this operation, all I have to do is call this function or call this procedure every time on the unsorted array, that's unsorted list. That's it. Just give the part which is sorted and give the number which is the correct number which you want to insert in the unsorted list and call this procedure every time. We would see that code also in the next slide. It's there.
Sir, the next line after the for loop, if not inserted, what is the significance of that line?
That's what, that's what I told, right? So once you do the insertion.
No, not that. After the for loop, for loop raises finally, if not inserted, new list is equal to new list plus plus X. Before return,
the last one.
That is for first or last one. Last
it is for the last one, yes.
Yeah, I am coming to that. So in order to go for that part of the code, we have to now take another scenario. So this is mainly happening for the last element as we suggested. So what happens if your X is this? So this case is clear, right? Let me go to the next case. It would be clear why this part, this lines are there. So X is lesser than the first Z, that is okay. So now I will go to another scenario where X is greater than all the elements in the list. It would then the last this part of the code would be understandable. Okay, now let us say our list is.
Sir?
Yeah.
So you are saying that this is the else part of if X less than Z, is it?
No, which else part? No, it's not else part, it's just a separate condition.
Okay.
Why this condition is given, you would understand. Just wait for a minute.
Okay.
Let's take another list, right? The first list, what was the condition? The condition was the element that I have to insert, that is X, that is smaller than all the element in the list, scenario 1. So that we have dealt with. So that is done. Now the second scenario is, by the way, so in that scenario, what would happen in this line of code? Inserted is anyway true, right? Because I have inserted X. And not of inserted would be what? False. So once this is false, anyway this line would be skipped. So I'm not executing this line of code in the scenario where x is lesser than all other elements. Okay. So, but this line of code would be executed in this scenario that I'm going to discuss. Let's say this is your list 1, 2, 3, 4. Okay. And the given number x is actually 5. So L is actually 1, 2, 3, 4 and x is 5. Now see what happens. So you would z would be so for each z in L. So this is the first iteration, z would be 1, and you see that x is what 5. 5 is lesser than 1, which is not correct. So this part would be skipped, and you come to new list equal to new list plus z. So what would my new list look after the first iteration? You put z in new list. So only 1. Z is 1, right? Z is 1. So 1 is put. This is my new list. Okay. Again, I go to the next iteration in the for loop for z in L. So now my z is what? 2. Right? And again I see z is 2. 2 is less than greater than 5. No, 2 is not greater than 5. So again this part is skipped. Whole of this part. Again I go over here and I make changes in my new list. So what would my new list look like now? 1 was already there. 2 is
so till 4 it will same happen.
Correct. So this step would continue till 4, right? Every time I would check 5 is lesser than 3 or 4, it would be false, and this would happen, and I would get the list like this: 3, 4. But now what? Once you have reached 4, your for loop has terminated. For each z in L was the condition. Now L is over. 4 was the last element in L. So L is now out. So now once L is over, your for loop has terminated, and your new list condition is this: 1, 2, 3, 4. Right? Obviously, now what you have to do is, since this is the scenario, what you can guarantee. So when you are at this point, right, you are moving out of the for loop. When your control flow is at this point, and your list is 1, 2, 3, 4, that is, you have not inserted x, right? X inserted value is still false, right? Inserted variable, we are only making it true when we are actually inserting x, right? But since we have failed in this if condition in all the possible elements, so this inserted has not been set to true. We have not inserted x. So at this point, your inserted is still false. You have not inserted. So what does that mean? That means you have gone through each of the element of the list, sorted list, and you found out that none of them is lesser than none of the given element that I have to insert, that is lesser than none of them. That means it is greater than all of them. Correct? If it is greater than all of them, then obviously I should place it at the end of the list. So that's what this line of code is doing in this scenario. So this line of code is particular to the scenario when the given number to be inserted is the number which is the greatest among all the elements in the list, and you need to insert it at the end. So now your new list has already been configured with all the element of your L list, and only thing now you have to do is simply insert x at the end. So how can we check that x has yet not been inserted? By checking the inserted variable. That's what I was talking about. So inserted would be false, and not of false would be true. So if true, so that means this line would be executed. So what I'm doing is new list plus x. So whatever new list was, that is essentially 1, 2, 3, 4, and with that I'm just adding x at the end. 3, 4, and 5. Fine. So this line of code is for the scenario when x is larger than all the elements in the given list. Fine. So this is done. So these two conditions are done, and where x is anywhere between them. So let's say now take another example. Let us take these two to be 8 and 9, and let's say my x is 5. Okay. So x is 5 like previously, and this is 1, 2, 8, 9. So obviously x must be placed over here, right, after 2 and before 8. So what would happen in the first two situations? Let us see that. This is the third possible scenario where x is neither at the x should be placed neither at the front nor at the end, but in the middle. So first z would be 1, right? Z would be 1, and obviously like that 5 would be x, that would be 1. Same condition would happen, and my list would be here 1, right? And again I would go to the next for loop iteration. So now z would be 2, and again this Z2 would be a false condition. So again my list would be 2. Now the third iteration is what? 8. So now this is 8. Now this is a true condition. See, 5 is lesser than 8. Fine. So the third iteration of my for loop. So 5 is lesser than 8. And there what I am doing is new list equal to new list plus x. So new list was 1, 2, right? We had new list like this. So at this line, new list is becoming 1, 2, and then followed by x, which is 5. And since I have now inserted 5, I make this inserted variable to be 2. Right. Now again the same thing I would do, whatever we did in the first example, right? Once I insert an element, all I have to do is execute this line. And this part would anyway not be executed because now my inserted is what? True. So once inserted is true over here, I have set it. After inserting, not of inserted would be false. So once this is false, this whole part would be ignored all the time. So every loop iteration of this for which you would only execute this line of code. And this line of code is doing what? Simply inserting all the leftover elements in it. So now 1 to 5 is the current condition of my new list. And this line of code for 8, it would insert 1 to 5, then 8. And then again in the new iteration, it would go and then Z would become 9. And then it would insert 1 to 5 at 9. Right? And not inserted would again be false because I have already inserted. So true of not is false. So this line would be again ignored. And then I would return my new list, which is 1 to 5 at 9 in the sorted sequence. Fine. So these are the all 3 possible cases: element at first, element at last, element in mid. Any doubts in this?
No.
Great. So now we would see that once you have achieved this, what you have to do is you have a sorted unsorted list. As you have, this is the unsorted list. Let's say this list is M. Let's name it M. This is an unsorted list. Can you guess? All we have to do is simply call this sorted insert method, right? And pass a subpart of M. So what I mean is you call the sorted insert method, right? And the parameter should be what? L would be what? M. And you pass only a subpart of M. Subpart of M means what? Obviously this subpart would vary by, let's say you have a for loop over here, right? Or a while loop over here, which is on some variable I or some variable, which would increase by 1 every time by 1. So you can simply pass your sorted part to be up to from, let's say, starting from 0 to I. Okay, the unsorted. So because every time it would be sorted, right? Every time you insert the current X element in its proper location, the sorted part would increase like this from left to right. So every time your for loop iterates, it actually calls the sorted insert on the next, on one more size of the array, 0 to I, and the new element would be what? M of I plus 1. That's it. So every I plus 1th element you are calling on the sorted list, which is M of 0 to I. If you remember the initial discussion we had, so this I plus 1th element, let us assume that this is a I length sorted list, and obviously this is my I plus 1th element there. So this I plus 1th element has to be inserted over here. So that's what we are actually achieving. Only sorted insert method by calling in this manner. So you would see the code now. See, so here actually it's made much more simpler. You even do not have to split it. So for each Z in L, what is L over here? Just a second. Yeah. So what is L over here? L is
list.
Correct. The list over there.
And list.
Yeah. So then your sorted list is the sorted list which you are actually which you would return as a result of insertion sort method. L is the unsorted list which you have, that the normal list. So sorted list equal to, you call this method, and every time you call it on the sorted list itself, right? And you return sorted list. So this sorted list is what? This is the part of, so here we are using a separate list to answer this question. In the previous code example that I wrote on the screen, so this is actually using the M itself. You can also use the same list itself without using another list. Just all that, we have not used this notation in our course, so that's why I mean it would be a little bit difficult for you to understand. But anyways, so if you want to use a single list, you can still do that, right? This is the idea. Basically, your part, you are sending the that subpart of the list to the sorted insert method, which is sorted, right? And that subpart is what? 0 to I. And I would increase every time using a for loop outside. And then you are inserting the I plus 1th element in that sorted sum. So this is mi plus 1 is the x element. So this is x and this is L of your sorted insert method. This L and x. Okay. So this is using the same list, but in our discussion over here, we are using a different list, and that's why it is much more easier over here. You just have a sorted list separate and just pass the sorted list and the current element. That's it.
So is this recursive?
Yeah, this is not recursive in that sense. This is recursive means you are calling yourself. Okay, this is not calling itself. I'm not calling insertion sort anywhere in this body. Insertion sort is the method of procedure. Okay. Recursive insertion sort is different. We would discuss that in I think in next week or when recursion happens. That's in week 11, I think. Yeah. Week 11 we have seen it. So recursive insertion sort is also there. In week 11 it would be discussed. Fine. So here we are using a separate list. You can write this code. This code is much easier to understand. But if you want to use the same list itself, that also you can do the way I discussed in that slide. So anyway, so this is how it works. So any doubt in insertion sort? Then I will move to dictionary.
No, sir.
Great.
No, sir.
Okay, so just keep that counting in mind that we did over here. So it's important. Maybe questions can come.
So minimum and maximum count.
Yeah. So once you understand the concept, it's easy. All you have to do is just use the number of element and then you would get the result. Fine. So now let's go to the dictionary concept. So main point of dictionary is that it's indexed by value. Okay, the whole point of dictionary is it's indexed by value. Or so till now what we have seen. So let us address it in this manner. So I told you in the start of this session that initially we use table, and on table we would fetch one record, let's say X from table 1, and then do some operations on that. So we had table as our only way to store data and operate on them. But now we are moving in the further weeks, we have moved to more realistic kind of ways to represent or to store data, which is list, which is multi-list, which are dictionaries, and further, I mean, we will learn more things in other courses as well. So these ways or this is kind of a structure, right? List is a structure. It's a way to, it's a container to store data. Dictionaries is also a container to store data. Obviously, each of these containers or structure differ in the way they work, right? They have their own properties, and that's why these are separate, and that's why I'm calling them different structures to represent data, and that is where the definition of data structures come. Okay, the different structures to represent data that you have. So list dictionaries are basically different data structures. Okay. And the techniques that you apply on this data structure to achieve some, I mean, to do some task, to write some code, that code is working on that data structure, on that list, I mean, on that list or on that dictionary to do some part, to achieve some, I mean, some goal, right? So that is what we call techniques or algorithms. So that's from there we actually discuss this concept of data structures and algorithms, and this whole point of CT course is to introduce you to the ideas of how the programming happens, and basically it's mostly about data structures and algorithms, so that we would learn in the PDSA course in detail. But anyways, so dictionary is just like another data structure, and the whole point of the use of dictionary or the invention of dictionary is that we are now wanting to reference data on the basis of the value and not by index. So in list you actually can only reference a particular value stored in the list by using indices. So what I mean is by using 0, 1, 2, 3, 4. So if I have a list L with the elements 1, 2, 3, only way I can reference 2 is by using L of 1. Right? I don't know where 2 is there. So while I am defining this list, I know L contains 1, 2, 3. But let's say someone who does not know what L contains, but know the existence of L is there. So he does not know what value is there in L. Okay, so he cannot do. He on all the only thing that he can do is he can run through all the elements in L by writing a for each loop. For each I in L, you can print I something, or you can use I. That's the only way he can do it. He does not know what values are there in L. But let's say in some situations we need the value we need to reference the value on the basis of some information that we already have. So let's say I want to represent the data of the populations of each state in India. Okay, so I can store it in a list. Fine, you can store it in a list. L of, let's say, some numbers are there. Suppose 20K, let's say 30K, whatever. Some numbers are there. And these represent the population. But let's say you created the list and you know that the first state is, let's say, Himachal Pradesh. You know the second state is, let's say, Rajasthan or whatever. But someone who does not know it, that what's the order, right? He cannot know that which value is which state's population, right? Although he knows that there is a list L which stores the population, and he also knows that there are so many states in India. He knows the name of those states, but he still cannot fetch the information that he requires because he does not know the order in which the states are embedded. I mean, the populations are embedded in the list. Okay, so that's when we actually require this data structure where I can fetch my required information by knowing some information, some partial information. So that's where I get the idea of dictionary. So let's say D is my dictionary and use. So this is the way of representing dictionary. I would have, let's say, Himachal Pradesh, HP. This left, and then I would have two colons, one colon, and then here I would have, let's say, 20K, comma, let's say Rajasthan, or let's say 30K, whatever, and like this it goes, and I close the dictionary.
So
here, yeah.
Sir, when do we write it in within double quotes? HP colon double quotes. Should this 20K come inside double quotes, or only when it is a string you get?
It's a string, yeah. If it's a string, it comes inside double quotes.
So okay, fine.
K means 1000. I just wrote in short.
Thank you.
Sir, may I ask something?
Yeah, please.
Sir, in list it's logical. I mean, we are going through all the elements and finding the required element.
Correct.
Value. But in dictionary, how come? I mean, what is going on that the program can find instantly that value?
Yes.
I mean,
yes,
may be something. I mean, how it is? What is happening behind the?
What is happening that you are seeing? That's the part of CT course that's I'm discussing, right? That what is happening that you are referencing it using value, but how it is happening is a part of PDS. So I mean that's quite detailed. So actually this is what we call hash table. Okay, this is something called a hash table. Dictionaries are basically hash table, or in some languages it's implemented using red black binary. Just stating these facts, do not get overwhelmed by all these things. You would learn this in PDS. So red black binary trees. Although red black binary tree is not there in PDS itself as well, but you would learn some version of binary tree PDS. But these are actually hash tables or red black binary tree, and there is a hashing mechanism that happens. What is hashing and all those things are there. You will discuss those things in that course.
I know this is not required, but I just asked out of curiosity.
Yeah, got it. It's very interesting. In the algorithms courses, we would see them in details. Okay.
Thanks, sir.
Sir, something directly related, may I ask?
Yeah, please.
Just in this line, sir. Sir, can the keys be of different data types? Like I have 10 keys and some are string, some are integer, some are character. Is it possible for a
correct. In CT, we are mainly dealing with a uniform kind of key given to the dictionaries, but because this is not a practical language, it's just a kind of conceptual understanding of how things work in real languages. In many languages, you can have different kinds of keys. I mean, it allows you to have keys of different types. But in 90% of the languages, you would see that even if you give a key of a different type, so let's say your first key is a string, but and the second key you want to give is a number, so that number would be automatically converted into the string representation. So let's say your first key is London, and you have some value corresponding to London, and your second key is 24. So as soon as you write your D of 24, that 24 would be converted into the string representation of 24, not the number 24, not the numeral 24. It would be the 24, the string 24. Okay, so basically it converts everything, it typecasts everything to string, most of the languages, right? So basically it's uniform and it is string mostly. The keys are string mostly in most of the languages, but some languages allow you to have different types of keys. Okay, so that is specific. Yeah. But mostly it's uniform only, and that uniformity is on the basis of mostly string. Okay, so if you have a uniform numeric key value, so 1 comma some value, 2 colon some value, so then in languages dictionaries keep them as numbers as well, numbers only, because all of the keys are numbers. But let's say if you try to give something like this 1 colon some value and then 2 colon some value, but after that you write, let's say Wednesday and colon some value, then obviously to treat all of these as string. We don't typecast all of them in this.
Yes,
This is anyway string. Yeah.
So the first data set makes more sense because it is more structured. The second one doesn't make much sense. So yes, sir.
Yeah. So yeah, that is correct. Obviously, that's correct. But it's not a proper way to say that it does not make sense, because now this we will learn in DBMS course that there are different types of data, that there can be unstructured data as well, right? So in unstructured data, different types of keys matter. So if you are aware of the JSON, are you aware of JSON? What is JSON?
No, sir.
Okay, no problem. So anyways, these questions, multiple questions would come in this initial phases. So all these things would be clear as you go through different courses, right?
Thank you for taking the data out. You may proceed with the topic, sir. Thank you.
Yeah. Fine. So let's come back to the discussion. How the dictionary works is not our concern now, but we only have to know that I mean, what does it provides us. So now the main idea is, now since this guy now knows the state names Himachal Pradesh, Rajasthan and all, he can actually fetch the required value just by using the state name as their index. So here I use 1, 2, 3, 4 as the index in list, but here I can write HP. And that's it. Whatever. So D of HP would fetch me the, so let's say this is population of Himachal Pradesh. So pop HP would be storing 20K. So I did not know what is the order or anything. In fact, in dictionary there is no order. So in list the order is the way you can see a list, right? 1, 2, 3. So 0 is 1, 1 is 2, and 2 is 3. This is the order in which it is there. But in dictionary, I wrote here HP 20K just for representation purpose. But internally in the system where dictionary is stored, right, there is no specific order. You cannot traverse through a dictionary like that, assuming that every time my 1 would be, I mean, D of 0 would be, there is no concept of D of 0, D of 1, D of 2, like list. These things are totally random. I mean, they are represented in a different manner inside the system. Okay, so
it allows random access.
It's random, not random, I would say. See, the thing is, so okay, since I mentioned the term trees, so basically these are represented in the form of trees. So these, let's say these are nodes. But don't worry, just consider this as trivial. So suppose this is a structure, and each of these nodes are basically your these values. So suppose R30 is over here, and let's say HP 20K is over here, and all other nodes are like this. So this is random. Okay, so sorry, not random. This is actually on the basis of a particular mechanism, a particular strategy, or an algorithm on the basis of which this structure is made. Not random at all. Not random. It's not random at all. So, but when you see, when you cannot see this working, right, this internal working, then you would think that it is random, because you would get HP 20K maybe at the last and R30K before that or after that. Then you would see that is happening randomly, but it's not happening randomly. There is a structure inside of it, and that structure is not sequential. Now I got the term. There is a structure, but that structure is not sequential. Like in list, it was a sequential. But here it's not sequential, it's non-linear. Okay, so non-linear structure is there. But it's not random at all, okay, keep that in mind.
So I mean random access, we can access the dictionary in a random order, whereas in list we have to sequentially, means ordered list, we have to go 1, 2, 3, whereas in dictionary we can have a random access. So we can write R colon 30K first and then HP colon 24, means it can be randomly accessed whenever we want. We can directly go to R, so D square bracket R, instead of like going from HP to R.
Correct. Yeah.
It should be called instant access, sir, instead of random access.
Sure. Yeah. So that's the idea. You need not actually think about the sequence. All you need to think about is what is the key. Once you get the key, you can get the value. So you need not worry what is the way.
It's basically like a primary key in a database, is it?
Exactly. But I cannot refer to that term. In fact, it is like that. Primary keys are implemented like this hash table only, hash dictionary only. But anyway, I cannot refer to that term because that's not. I mean, we have not done that course.
Okay.
So anyways, so this is dictionary. So we would use this key values to actually fetch the data, and the main idea of dictionary is indexing using values, and the main feature of list was indexing using indices or position, right? So indexing with value, indexing with values or data, whatever you want to call. So because this is your data or value, on the basis of that you are indexing. Fine. So since we have, so this is what I was telling. Source station, this is a number, but it is actually converted in the form of a string. I mean, here we are passing it as a character, as a string itself, and inside the dictionary also this number is represented in a string format. So in CT, we are mainly dealing with a single type of uniform key type, key data type. Okay, so there is nothing different in normal dictionary to discuss anymore. You can have this key value pairs where you have a key and the corresponding value attached to it. But now I would actually discuss one part, which is the value inside this dictionary, right? So here you see Rahul is the key and 93 is a value. Clarence is a key and 73 is the value for that. But I can have values. So these values can be of different types. And when I say types, they can be of different, not only normal or primitive types, but also they can be separate data structure. Correct. They can be separate data structure itself. So let's say I have a dictionary, D itself, D, right? And so I have a key, let's say, how should I? So anyways,
student ID card.
No, I would take a more practical example corresponding to your further weeks. So I told you that we will use dictionary to represent graphs, right? And I'm assuming since this is revision session, you all at least know the basics of what a graph is. So what I would try to do now is I'm drawing something over here. Let's say this is my graph. This is A vertex, this is B vertex, this is C vertex, this is D vertex, this is 5. The weight of A to B is, the edge from A to B is weight is 5. The edge from B to C's weight is, let's say, 3. B to D is, let's say, 10. This is 2, this is 1. So there is a graph and we want to represent it. Now the matrix representation of graph would be discussed in the corresponding week. But what I want to say is how you can represent this data in the form of a dictionary. Okay, so how can I do that? First of all, I actually skipped one part. Let us assume initially these weights are not there. Just assume this 5, 10, 1, 3, 2, these numbers are not there. We just have unweighted edges, or where all the edges are there with no separate weights, with no separate values. Okay, so just assume these edges are there. So how can I represent that particular graph? So I can use a dictionary D. Okay, and I would first represent, let's say, a vertex A. Okay, and then I can have a list. Okay, because see, A is connected with B and D. So I cannot write A, B, so if I do not use a list, that's what I was saying. So if I do not use a list, I cannot write something like this, A, B and AD. Because one very important feature of dictionary is your key value should not repeat, they should be unique. So A is connected with B and D, but I cannot have two separate entries, A corresponding to B and A corresponding to D. So what I would do is I would use a list. So now let's do that. So A is associated with a value which is a data structure list, and that is B, and the second one is D. Then likewise I would have another number, let's say for B I would have A, C and D. So this is how I can use the dictionary with the list as its value of each of its key to represent a graph. ABC. Done. So this is my unweighted graph. Fine. Now let us see another example. This is a new D. Now assume the weights are there. 5, 10, 1, 3, 2. All these weights are there. Okay. So now what would happen? Can I write like this? Initially I had this B, comma D, but now how I put the weight as well as both the vertices B and D? Any idea?
So dictionary.
That's the answer, but
so
list.
like A to B will be A colon. So A colon, then again dictionary as a value.
Okay, but what I want to say is, I mean, I want to come to the fact that you need a dictionary. But before that, can you represent it anyway using list? That's my. What is the problem? So why I cannot have this representation when I have weights?
We cannot give the weight. We can
have key and value pair.
So
we want pair.
Key value pair is
so
not there in list.
Yeah. So the problem over here is because here in list I need to store the main point is, and this is the definition. The definition is how you can point out where you need to use dictionary, and you cannot work with a list. Okay, so let me just state this fact actually. So now in CT you are learning the computational ideas, but when you actually go for coding, you see that dictionary is a much heavier data structure or heavier tool to use in a program. So when you would actually write program in an organization or somewhere in a good place where your performance matters, right? So the lighter kind of data structure or lighter kind of space that you can use, right? Or the system requirement, sorry, not requirement, the system resources, the lighter system resources you use, your code would be much more economical to be, and that means your software would be much more economical, and that means your business would be doing much better. The profits would be more. So those things are there. But so that's why every time we write a code in real software development, we have to keep in mind that we use very, I mean, whatever is required, we use that. Don't overkill something. Don't go, I mean, because it is easier for you to write. We don't go for something which is very, I mean, which is heavy, which may be heavy for the system to run. So dictionary is a much heavier data structure. I'm not telling heavier does not mean slower. Heavier actually means it is faster, but since it is faster, it requires some underlying work that happens, and because of that, your system requires more work to do on that. So always, if it is possible, we would try to work with lighter data structures, but when it is not possible, we have to go for something good. So my point is always try to work with lesser kind of or lighter kind of tools. This is not relevant to CT course, but this would be relevant to your further program or in your further journey. So, but the thing is, what is the point where you can understand the dictionary is required and I cannot work with list? So this is that point, because you say that I cannot have key value pairs. So that is okay, but I can have something like this. I can have, let's say, A's value is B, right? And corresponding to B, I store something. Just a second. Someone is unmuted. Okay, fine. Can I have something like this? Let's say we know that nested lists are there, right? So sorry, not this.
Yes, sir. We can use list of list.
Yeah, so that's what I was telling. So I can have something like this: B, comma, what is the value? A 5. And then I can have other is D, right? So D, comma, AD is 1. Fine. This is fine, right? What's the problem? So I wanted this answer from you guys. That why I cannot have this.
Sir, we can have it.
We can have it, right? But still, but we know the answer, we would go for dictionary. So now my question is, what is the problem?
So, sir, we have to go in an order again.
We will have to compare every time. We have to find the neighbors.
So if we wanted to have D, then A.
Accessing the data is a little bit difficult here.
Yes, sir.
Exactly. Because when you actually you are representing the graph in the form of a dictionary or matrix in further ways you see, because you want to work on it easily, you will do some some coding on that, right? Now this is just a data structure that you are using, and then on that data structure you will do some work. You would write some lines of code on that. So the easier it would be. Sorry, not easier. So if you use this representation of multiple insert nested list, it will work, there is no problem. But again, as you all said, that it would be that sequential properties again coming. So you don't know which vertices are there with A, B, or any one of them. So or every time you actually try to access a particular node which is attached to, let's say, A, you have to travel the whole list of it. You want to see that what is the weight of the edge of AD. The AD edge, what is the weight of that? You cannot access it directly. Up to A you can access, but once you get A, you have to again write a for each loop for the list in corresponding to A. I mean, for this list, this whole list, the larger list, you have to write a for each loop for that, traverse that, and then you have to check when the first of your list. So what I mean is, how would you write it? You would do something like this: for each, let's say, element in let's say this is D, right? D of A. Okay. So this is, now you got the outer list. Here you would write if first of element is equal to D, then you actually get the weight, right? So let's say you store that in a variable W, D of A of element. So something like this you would do. But so this for each loop is what creating the problem here, because every time you want to go for a particular node, you have to traverse the whole list. So if you are writing a code which refers to this data structure, which refers to this dictionary multiple number of times, so every time you would actually go through the list, the whole list, traverse to the whole list. So that would take a lot of time. When we are not discussing about time complexity over there in CD, but it would take a lot more time, right? You have to get that information. So that's why the using of this multiple list, also we can do that, and obviously it would give us correct result as well. But the thing is, when we write code, it is more difficult for us to deal with that, both in the form of code as well as it would take more time because of the multiple use of the for each loops. So that's why the answer is also we can do that. We would move to the representation of dictionaries. So let's go for that. So now I would come back to your answers. How we can show it is simple. Now just add B, and corresponding to B add one more dictionary. Sorry, not dictionary.
Value.
So the value, yeah. So the value is 1, right? AB is 1. Oh, not 5.
5.
Right. And then what is the second key? Second key is D. So corresponding to D, my value would be 1. And like that it goes. So now I would have B. Again, corresponding to B, I would have a dictionary. A, which is 5. C which is 3, D which is 10. Accordingly, I'm not drawing the whole thing, but like C would be there and then D would be there, and each of them will have a dictionary. And this is the representation. Now I need not go for any of the looping things. I need to find the ADs where all that I need to do is D of A of D. That's it. Done. So this is your a single step operation, right? A single step operation. And in that case, earlier case in our list representation, it was taking me a looping, a loop of n. What n means? Let's say that this length of the list would have been n. So a loop n step operation or n step operation. So this is the advantage that we get with dictionary. Okay. Fine. So this is basically a weighted graph representation, and this is an unweighted graph representation. So when unweighted graph representation is there, we can simply do with list, and actually we should do with list only, do not go for dictionary. And when there is a weighted graph representation, we can do with list, but that is again a nested list, and once it is nested, I am having to use, I would need to use for each. That's why we are going for this dictionary approach. Okay. And that's kind of it. There is nothing very other new topic to the dictionary part. Now all we need to do is simply have to check different codes, practice different codes to get familiar with the how dictionaries work. Okay, so I would discuss some codes, but let us. Okay, so some of the methods that we would use to actually help us working when we are writing pseudocode is like keys or keys, right? So keys, if you pass a dictionary D and K, provided K, if K is a key for the dictionary D, then keys would return you true, something like that. Okay, so and this is the method of the procedure of how this keys works. You can just simply use a for each loop to traverse through all the keys of D, and if it is a matching, you make found equal to true and return the found. That's simple implementation. Right? So keys is now once we make this procedure, we need not worry about every time we have to check whether a particular value is a key inside a given dictionary or not. We can simply pass it to keys, the dictionary and the key, and it will return us the correct result, whether K is a key of the dictionary or not. Right. So checking for a key is done. Achha, and keys of D would return a list. So I think Nalini ma'am anyway discussed this, but so when I pass keys of D and provided D is a dictionary, so what would this return? This would return a list. It returns a list of keys of D. Fine. Okay, so this is a summary kind of thing. Now let us go to the next. So this pseudocode of dictionaries example I will discuss now. Achha, before coming to this discussion, since these are normal pseudocode discussion, may I ask this? So, is there any specific doubts or specific part of the dictionary or nested dictionary or anything, this complex kind of data structure where you have doubts? Now, discuss that first and then go for the solution. Any of you have any specific doubt in say nested list or nested
Not a
dictionary?
specific doubt, but sometimes when the questions occurs, then it is sometimes getting not clear, bit vague.
So that is actually has to do with, so you have to do more practice and see that how a dictionary or not dictionary, any data structure, any complex nested kind of data structure, you just first have to figure out it, the image in your brain. I think you all know about that, but it's difficult to do anyway. Even with understanding what you have to do, it's difficult to visualize. But that comes with practice. You have to see that.
Mainly when we are doing this graphing part, the visualization becomes very difficult and confusing because of the matrices I, J, J, K and all.
Correct.
So that I think eventually comes out of practice, but we have very limited time to basically go through many codes. So
I understand.
that is the issue.
Sir, regarding the same thing, I wanted to ask, like at the last moment, what is the efficient way of doing revision? Like we have already gone through all the lectures, but as a revision, we cannot go through those lectures again.
No, don't go through all the lectures. What I would
Yeah.
say is go through the pseudocode. Because lectures is just the idea of how things work,
Yeah.
and then right, pseudocode is the main thing that you have to do from your exam perspective. So you have to understand most of the time it would be pseudocode. You have to understand and write the answer. So and some theoretical questions. So I would suggest go through all the pseudocodes which are there. As a part of the lectures, you all on the slides. Download the slides and just go through all the slides whether they are understandable to you or not.
So
So
the
that would be-
the
Yeah.
slide which you are referring, does this slide contain all the pseudocodes?
Yeah, also, so there are two kinds of lecture, right? One is where the professors are discussing, and one where professor is explaining a pseudocode. So, where those lectures where professor is explaining a pseudocode or teaching something in a slide, all these slides contain all those things are there. So, you can refer them.
Okay, so thank you. Yeah.
So I would suggest do not go through lectures as of now. Lectures would take a lot of time and it would not be beneficial in that sense. If you have fundamental doubt, which you should not have at this point, then lectures are important. But as of now, just go through all the slides and go through as much practice question or activity question, not activity but practice question as you can. Go through the graded and practice question, go through the pseudocodes. Okay, so that's what is important. And regarding the graph week, I think I don't know whether it would be much helpful because anyway it is more related to practice. But I would suggest to go through one of the sessions where I try to draw the graphs and have pseudocode written, have a parallel between the pseudocode as well as the figure drawing. So if you can go through that session, I hope somewhat it would be easier for you to visualize. But anyways, at the end of the day, it's totally on your practice. So I think graph is in week 10, I think. Yeah, so week 10 live session, open session. Go through that. Hope it would help you a little bit.
Okay, sir. Thank you.
So, okay, so since there is no specific kind of doubt, I will just discuss some examples over there.
So can you discuss, means I don't know whether it is, you have already explained or not, but in quiz 2, we had this word table is procedure is rich, find a word Y, where like, there was a pseudocode, if you have the.
Okay, wait, so have it now.
It was question number 41. And it, so it was a dictionary.
Give me a moment, I have to just search whether I have that.
So where we can this have slides?
The slides are there on the portal. Go to the supplementary materials. So over there you can find PPTs and slides.
Okay, but actually those are from week wise, ma'am. Sir, I need this all that this is what ma'am and you have covered now. So can you share this one with you?
Okay, so this is already there. I have downloaded from portal only. These slides, week wise only it is there. But the Nalini ma'am use the slides, right? So those slides I would ask her to share.
Where we can get, sir?
Sir, these are also, I think, there in week 12 tutorials.
Oh, week 12 tutorial it is there, no? Okay, yeah, fine.
Okay.
Okay, so yeah, so regarding that question, what was it? Is rich.
So how to go about it?
Yeah, okay, I'm just finding whether it is.
So it was a dictionary, and they had asked us.
Okay, I think I got it. Okay. Let X be a row from words table. I'm sharing the question. Let me just confirm whether it is it or not. Is rich and the return value of is rich will be false. This question? I mean, is
Yes,
it,
sir.
okay. Let me just go through it. Okay. Wait. Fine. This is it, right? So length of keys of BT greater than equal to 3.
Yes, sir.
Fine. Yeah. So let us go to the option. See, so so when it is false is asked, so when is rich, y will be false. Okay, I would go through it line by line, but you see that whenever, so this is one thing that I want to say. When you are writing or in the exam, right? First see the question. I think I mentioned it earlier also in before quiz one. First see the question and first see the options. Then you go to the code. Okay, first see the question. Question in this part, right? All. Do not at first see the try to understand the pseudocode completely. Obviously, you need to do that, but before that, try to see the question and try to see the option at first. Then you go into details of the pseudocode, because that would help you to figure out which part of the pseudocode is important for answering your question. Okay, it would give you a better sense and it would make your time less. Otherwise, you would actually go through the pseudocode, then you would read the whole question as well as go to the options, and then again you would need to come back to the pseudocode to refer the specific parts. So that takes some time. So I would say that's a general tip how you can do it in lesser time. Okay, so once that is done, now you see that here is rich y will be false. So you need to see where false is returned. So you see false is returned in line number 14. So all you need to figure out is when line number 14 would be executed. Right? So line number 14 would be executed when this is not executed, because it is a if and inside if there is a return statement, line number 12. So once return is done, line 14 would never be executed, right? So when this is false, that's what you have to think about. I mean, this condition is not holding true. What is this condition? This condition is checking that the dict is one dictionary. Now I don't know what that dictionary does, but the keys of the dictionary is length. So basically the number of keys present in that dictionary, if that is greater than equal to 3, you are returning true. So that means if the number of keys present inside that dictionary, if that is lesser than 3, then I would return false. So is rich y will be false when the number of keys in my dict is lesser than 3. So I can just tell it from by inspecting only this part of the code. Okay, so now I have to inspect this part of the code and see that when is that condition happening, or what it is actually happening inside the pseudocode, so that which is making my dict dictionary's number of keys to be lesser than 3. So let us now see what is happening. So here I have I equal to 1 and a is a normal a blank character. After that, what I am doing is, so this is from the words data set. I am taking I less than equal to x dot letter count. Okay, so I is a variable and I is lesser than the number of letter count in each of the words. That the current word that I have picked is x, right? From usage method, x is passed. So since I is 1, I am assuming any word would be at least a single character length. So that's why this condition would, this while loop would be iterating at least one time. So then I would go in A equal to ith letter in X word. Okay, fine. So you take the first letter because I is currently 1. If A is a vowel, then you set V-dict of A equal to true. Now, if A is a vowel, then you set V-dict of A. What is V-dict of A? That means, if let's say A is a vowel, that means consider the vowel is O. The current vowel is O. O is a vowel, right? Assume that the word that has been sent to you, that is X, it has O in it. So when I am through that word, yeah.
Can you take any word and explain?
So the vowel letter will get updated, will get added to the dictionary, and the value will be set to true.
Correct. Correct. Why did I click? Yeah. So okay. I can write over it directly. Just a second. Fine, let us see now. Let us take the word to be. Okay, so let's take a word from the option itself. Fine, let us take a word online. Okay, so it's one of the options. Fine, so my current word is the color green visible or should I change it to something else?
It's visible, sir.
Visible, okay. So let's say the word is online. Right? So X is online, that means not word, sorry. This is X. Assume that X is corresponding to the word online. Now what I'm doing over here, I less than equal to X dot letter count. Letter count is basically over here 1, 2, 3, 4, 5, 6. 6 letters are there. So X dot letter count is 6. Correct? So if X dot letter count is 6, right? And I is what, 1. So 1 is less than equal to 6. So no problem. My while loop executes. A equal to ith letter in X word. I is currently 1, right? So the first letter. So equal to the first letter. So first letter is what? O. Okay. So A is a vowel or not? O is the first letter. Yeah, O is a vowel. So what I am saying, V-dict of A equal to 2. So now see, this is my V dictionary. Fine. And obviously, initially my V-dict was empty, but in the first iteration, I just insert O over here because O was initially not there. So O is inserted and I'm setting its value to 2. So this is my V dictionary as of now. Now I equal to I plus 1. Okay. So I was initially 1, now I'm moving to 2. So again the while loop starts from 2 and obviously 2 is lesser than 6 and that means the second letter in X1. So now you see that this is what's happening over here is we are simply traversing on each letter of the word given to us. Right? Now I is N. Okay. So if now I is N, so if N is a vowel or not is the next scenario. So this is not O, this is N. If N is a vowel and N is not a vowel. Now, since N is not a vowel, there would be no change in my V-dict, right? This if statement is not executed, and I would be increased by 1 more again. So now I is again increased by 1 more. So I is now at L. Same thing, L is again not a vowel, right? So this is L. A is L. L is a vowel. Now L is not a vowel, and this is 3 by the third letter. Third letter. So L is not a vowel, so again no change in V-dict, and I is increased by 1. So now I get to I, right, because The fourth iteration is a tie, and I is a vowel. So again, this time this condition should be satisfied, and here I would get the I is a vowel, and verdict of I would be true. So now I add another entry over here. Done. So basically, what we are doing is we are traveling through each character or each letter in the given word, okay, and then we are checking if that is a vowel or not. If that is a vowel, then we are adding a true entry corresponding to that vowel in the dictionary, and that's it. And then we are moving to the next character. And then once this loop ends, when the word is over, then what would happen? Since we are traveling on each of the vowel, so here I would have all the vowels set to be true. So O, I are the two vowels till now we have found. Next, N is not a vowel, but E is a vowel, right? So E would be also set to true. And that's it. So this is my V dictionary at the end of this line, 10th line, right? When the loop is over. Now we are checking if length of keys of verdict. So keys of verdict would be what? Keys of verdict would be O, I, and E. So this is your keys of verdict. And then you are applying length, right? 3. So this is 3. So if that is greater than equal to 3, so equal to condition is holding, then you return true. So when I have online, it is returning true. And why it is returning true? Because the number of vowels which is present inside online, that is nothing but the number of keys inside the verdict dictionary. And I told you that we will only return false when the number of keys inside the dictionary is less than 3, which essentially means when the number of vowels inside the word we are considering is less than 3. So you have to search through all the options and figure out that word where the number of vowels, unique vowels, is less than 3. Got the point? So now if you see, there are the options where see continuous is there. Now continuous, how many vowels are there? O is a vowel, I is a vowel, U is a vowel. So 3 vowels are there. This would return true. Computational, O is a vowel, U is a vowel, I is a vowel. Again 3 vowels. Okay. Now online we already saw that it returns true. But science, what is happening? See, only I and E are 2 vowels. There is no other
had to check only for unique key unique vowels, not the repetition.
Yeah, because key cannot take duplicate, no?
What does this line do? We are not adding, we are not doing +1. We are just simply setting it to be true. So even if you get a repeated E or O or whatever, it would again be simply O of true.
Got it, sir. Yeah. Thank you, sir.
Okay. So yeah, that's it. Simple things. Only thing is you need to figure out what's happening, and I would request all of you to at first see the question, see the option, then go to the solution. Okay, that would save your time. Yeah. That's done. Okay, the side effect thing is basically it's not very relevant from your exam perspective. It's basically what happens if you kind of modify the data structure on which you're currently working while in the process of working, right? So these kind of codes mostly would not see in exams, or it would not be asked in that reference. But these are very, good for you for understanding good coding practices. Okay, and only one point is there that when you are this statement actually. So this is a new kind of thing. So where you are returning the same parameter on which you are working. So this actually keeps track of any changes that you do in the data structure in list or dictionary, whatever you are using. So MYD is the dictionary on which you are working upon, and whatever changes you do, you can, what you are doing is you are reflecting that changes in MYD itself. So that way, whenever there is again a delete key to call on MYD, you can be sure that all the updates are properly reflected. Right? So this is a very commonly used technique in any programming, that the parameter on which the parameter to a function or a procedure that you pass and work upon that, if you do some modification on that structure, what you do is you return that structure as well, and you store that structure in itself. So this is basically updating itself. Okay, so once it updates itself, you need not worry about whether a change has been reflected or not. It is obviously reflected, and the latest changes would be there in the structure when you again call this method or some other method which uses this structure. Maybe dictionary, maybe list. So yeah, so that's one simple pointer. Like this. Insertion sort my list. You are modifying my list, and that's why you are returning it as well into my list, so the changes would be reflected. Here you are modifying my ID, so you are returning my ID itself, so the changes are reflected. The latest updates are there. Okay, so that's about side effect. Any if you have any doubt, there is nothing to be doubt. These are just good coding practices. And yeah, most probably all of these, we will not ask any question. I mean, we don't have any way to ask a question on these topics. But fine. So now let us see a few code how dictionary works. Nothing difficult also. Just I will take one example over here. So this is where we are actually transitioning from table to dictionary. Okay. So transition from table structure to dictionary. What we are doing is we have a table, right? We are reading each row X from the table 1, and we are, let's say X is the that row's name identifier, and then customer name is an attribute for that particular row, and we are storing it in a variable customer items, and then we are using a for each row in items. Now that means what? Items is a list, right? Items is it's a list of items. Now for each row in items, what we are doing is if row dot category is food, and if is key of food customer. So why it is key of food and customer? What we are trying to do in this is we are trying to pick up each item, right? But find the customer who's buying the highest amount of food items, right? So we need to search the items which are there, and on the basis of those items, we need to have the number of times that item has been bought. So my dictionary would look something like I would have customer. And that customer ID or whatever it is, the customer name, right? ID name. So corresponding to that customer, I would have an item, right? Number of food items purchased as well. So then I would have how many items that particular customer has bought. So that is some numerable, some integer. And then again, I would have customer 2, right? And some other integer value. So this is basically the kind of dictionary that we are trying to create from the data from the table. Okay, so if you are checking if the categories, yeah.
Basically, count of food items a particular customer buys. Is it?
Yeah, correct.
Number of food items.
That's it. That's it. And items is there in a list, so all you need to do is simply check how many characters are there in this for each row, and every time you get an iteration of this for loop, you increase the count by 1 because each iteration itself is an item. So you increase the food customer of that value by 1 dictionary value, right? And if is key is not there, right? So let's say the first time when you get a particular food, I mean the customer item, the first key you get, right? So let's say the customer name is let's say Abhishek, right? Abhishek is the first customer, and before this Abhishek was not there in the dictionary. So the first time you are encountering Abhishek, your is key of Abhishek would is key of customer would return false. So sorry, this would return false, yeah, because in your dictionary, food dictionary, you do not have the Abhishek key as of now. You have encountered Abhishek customer for the first time. So in this case, it would be false, and but I need to add Abhishek in the dictionary, right? So this is what the else statement is doing. It is just simply adding Abhishek in the food key dictionary for the first time, right? And it is setting the value of Abhishek's item count to be 1. And the first item Abhishek has got. And after that, if I get further items for Abhishek, right, then this would be 2, right? Because now I have added Abhishek in the key. So then this if statement would be true, and then I would simply increase the already initialized 1 value corresponding to Abhishek in food D customer by 1, right, for the next item. So for new encountering of value, this is where we do the initialization. For subsequent encounter of the same key, this is where we do the update. That's it. Simple code. Any doubt over there?
No, sir.
Yeah, this simple things of nothing difficult over here. Okay, so I would again ask if you have any specific doubt in dictionaries, you may ask. Or yeah, otherwise I would then stop the session. Or any doubt, not only dictionary, any doubt if you have also.
Hello.
Yeah.
Sir, am I audible?
Yeah.
Sir, can you please differentiate between unique and most often and distinct?
Most often means the number of frequency. So you count how many times it's happened, right? Whoever is maximum, that's your most often. And unique is simply, I mean, so whenever you get unique, I mean, so you have to just check which is unique. I mean, so let's say this example only. So here, if an item count is 1 corresponding to a customer, right? So let's say this is a dictionary that you created, customer 1 and item count is 2. Then customer 2, item count is let's say 5. Customer 3, item count is 1. Now I ask you a question. In the table, right? In the table 1, which okay, not in table.
I'm unable to watch your screen. Actually, I think there is some problem here.
Okay, is anyone else having problem watching the screen?
No, sir.
No, sir, it's visible.
No, sir, it is absolutely visible.
Sir, can I reconnect with you, sir, if you don't mind?
Okay, fine. Please rejoin the session. Okay, anyone else any doubt? I think doubts will be there more in the graph part, but I think graph part will be taken. I would not take that, someone else would do that. So,
Sir, will we have a revision session?
Sir, I'm reconnected, sir. Hello?
Yeah.
So you were asking something.
Yeah, can you see the screen now?
Yes, sir.
Yeah, I was asking that, I asked you this question, given this dictionary and the pseudocode that I have just discussed. The pseudocode is simply that I will have the customers as my keys and the number of items that they bought, they are values, right? So if I ask you which customer has bought only one item, so you can see from the dictionary and tell me that customer 3 is the one who has bought only one item, right? So, but that is not unique. So this is what I want to say. So unique means you have multiple occurrence. You would not have multiple occurrence of same item. Okay, you would have a single item occurring only once. That's unique. And most often means. So if I ask you which customer has bought most often, so here the answer would be customer 2 because he has bought 5 items. Okay. So simply, I mean, normal English terms. You only have to be careful about how the pseudocode looks.
So unique and distinct are the same or are they different?
Unique and distinct are same. There is no difference between them.
Oh, okay. Thank you, sir.
Yeah, I think someone else was asking something in the middle. We just.
No, sir. I was only asking whether we'll have a revision session on the topic graphs.
Yeah, obviously. This is only up to week 8. So you would have session on 9 and 11 will be there, right? So revision session for those 3 weeks will be there.
Okay, sir. Thank you.
Sir, what about the mock? Is there any?
Mock, I think. I'm not sure about, but I think there is a plan to release a mock. I'm not sure.
It will be before 8.
Yeah, I'm not quite sure about the mock.
Yes, sir, because in the calendar it is mentioned mock revision.
Yes, sir. Revision on 8, so it will be before 8.
Okay, then fine.
Sir, if there is a procedure called remove duplicates.
In which, where?
No, sir, in CT only, sir.
I understand where you are calling it duplicate.
No, sir, I have doubts. Sir?
Is it in the slide or is it in any question where remove duplicate? Where is it?
Sir, actually, in the last revision session, Rahul sir took repeated and some duplicates, something like that.
Before quiz 2.
I'm not aware of that. Is there anywhere in the slide or then I can answer maybe? Remove duplicate maybe most probably it is from list. You are removing duplicate, something like that.
Sir, he explained actually remove duplicates means if in the list there is a 1, 2, 2, 3, 4, 5, let's say. So in that case, we have to remove both the two because it is duplicated. Duplicated mean, I mean repeated and unique, both are different. That's what he explained in the class. Like if they ask remove duplicate, that doesn't mean finding out the unique list. It's different. Unique means it will have 1, 2, 3, 4. But if they ask remove duplicate, duplicate, that means we have to, the list will be, final list will be 1, 3, 4. We have to remove both the twos.
Exactly, sir. That doubt, sir.
Okay, so see, so if there is any question that's coming in this manner, so I think output, what is desired will be clearly communicated because these terms may vary depending upon context, right? So any question that would come, it would consider, it would show you an example that what does it mean. Okay, so some example, let's say this is the list. After running the method, it would look like something like this. So you just see that and then work upon it. Okay, so because there can be interpretations if you have to remove an item totally from the list which is repeating, then there can be both interpretations. Either you remove the duplicate item or you remove the item which is there duplicated totally from the list. So yeah, I think if any such contradictory thing happens, it would be communicated to you in the question for itself. You are not feeling difficult. Okay.
So in this food pseudocode, if we are counting the number of food items, then why we are not using only count and then we are going for dictionary, or we are specifically looking for various items in the food like milk and all, and then we are counting separately?
Items can be multiple, right? So are you telling that why we are not simply adding the length of items?
So why we are not only using a count? A count is equal to, we are not initiating count is equal to 0 and then we are counting the food.
You have to do that for all the customers, right? So you must do it in the dictionary. That's what. So this is what you have created.
Yeah, got it. Okay.
So that's why you are doing. Since you are doing it in a dictionary, for each customer you have to do it, and that's why we are doing. If there is a single record, then we would have to just use the variable count and increment it one by one. Okay, fine. So yeah, so we would end the session now. Thank you all for attending. If there is no other doubt, if there is doubt, you can ask now as well.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Good night, sir.
Fine. Good night.
Thank you, sir.
All the best.
Thank you.
Thank you, sir.
Thank you, sir.